Special right triangles, area of triangles, and word problems. This is chapter 10.2, which is our next lesson in trig. Special right triangles are 45, 45, 90s, or 30, 60, 90s, where these angles are 45s, and that's a right angle, or this is 30 and 60, and that's a right angle. They're called special right triangles, and they're of importance because they come from common scenarios. A 45, 45, 90 is just half of a square, right? If this is a right angle, then these are both going to be 45 degrees if you find the diagonal of that square. So let's call this side C and this side A and this side B. Well, if the side length of the square was 1, then the hypotenuse is going to be Pythagorean by doing a squared plus b squared equals c squared, where a and b are both 1. Well, 1 squared is 1, 1 plus 1 is 2, and I'm going to call that c squared still. So 2 equals c squared, so root 2 is c if I square root both sides. So c has a length of the square root of 2. So we can often make this just 1, 1, root 2, but sometimes we'll talk about this scenario where the hypotenuse is length 1 or length anything else. We'll get there in a second. But that 1, 1, root 2 relationship is of importance. With 30, 60, 90s, well, an equilateral triangle has 60 degrees everywhere. All these angles are 60 degrees because they're equilateral, which also means that all these sides are the same. So we can call them all 1 or 3 or 12 or whatever. I'm just going to call them 1. Well, if we take half of an equilateral triangle and drop down this height right here, these two lengths are now the same. I'm going to switch colors to show the difference. So if this was length 1, then each of these is 0.5, or a half. And this angle up here, this little angle right here, is now 30 degrees. So we have this is 0.5 and this is 1, so the question becomes, what is that over there, which I'm again going to call letter B, because this over here would be letter C. So I'm going to jump up to the equilateral triangle now. If this is 1, then this is a half, so the question is, how can we find side length B over here? Well, we know that a squared plus b squared equals c squared, so a quarter plus b squared is 1. So b squared is 3/4, because 1 minus a quarter is 3/4. I square root both sides, and b equals the root 3 over 2, square root of 3 over 2. So this would be root 3 over 2. Now that is only if this length here is 1. If this length was like 4, then this would become 4 over 2, which is just 2, and this would become 4 root 3 over 2, which is just 2 root 3. So these relationships you want to get memorized. You want to have them really, really just solid. The point being, if this is 1 and this is 1, then this is root 2. Or you could pick any angle to be the, any side to be the side of reference, the side you're working with. Like suppose that the hypotenuse was 1. If the hypotenuse is 1, well now I know that a squared plus b squared equals c squared, which is 1 squared. But I also know that a and b are the same. So this a squared plus b squared, I could actually just call a squared plus a squared because they have the same length. So 2a squared is 1, so a squared is a half. So a is the square root of a half, which is, the square root of 1 is 1, so it's 1 over root 2, which rationalizes to root 2 over 2. And that number there is of critical importance. If this is length 1, then this is root 2 over 2, and this is root 2 over 2. And now everything can just be a multiple of that. So suppose the hypotenuse was 3. Well, 1 times 3 got me this, so I would do this times 3. It'd be 3 root 2 over 2, and I would do this times 3, 3 root 2 over 2. Or suppose the hypotenuse was 6. I'm going to run out of colors here really quick. If the hypotenuse had a length of 6, I would just do this times 6. And 6 root 2 over 2 is really just 3 root 2. These are both 3 root 2. And if, say, this had a length of 5, so now I'm going from this side length of 5. Well, then this is also 5 down here. And what does this become over here? That's the question. Well, it's just root 2 longer. So it's just 5 root 2. So you're always going to be multiplying by root 2 or dividing by root 2, depending on which direction you're going. And now this triangle looks really full and really crowded and kind of gets stressful. But you want to be able to just move really quickly and fluidly between sides of these triangles. Let's talk about this 30, 60, 90. The important thing to really understand is whatever length this is, the short length is half of it. So if this is 1, this is a half. And if this is 3, this is 3/2 or 1.5. You would think that the 30 would be half of 60, but it doesn't work that way. The 30, which is this side here, this side is opposite the angle 30 degree. The length on this side here is half the hypotenuse. It's not half of the 60-degree side. So please try to remember that. So if this is 1, this is a half, and just remember this is root 3 over 2. So let's say this became 2. Well, this is going to be 1, it's half of 2, and so this is going to be root 3, because this side over here is always root 3 times this side. So I'm just going to keep doing examples. Let's suppose that this side was 6. Well, this side over here would be 6 root 3, and this side over here would be 12. Because from here to here you double, from here to here you do times root 3. And let's say that this side, I'm going to jump to my ugly, ugly green. Let's say that this was 5. Well, this is the most confusing one. If from here to here we did times root 3, then from here to here we divide by root 3. So this becomes 5 over root 3, and I can't have a root 3 on the bottom, so it's 5 root 3 over 3. But then we just double, so this becomes 10 root 3 over 3. I recommend you do this in class with your teacher if you have a teacher, and if that's me, we'll do it in class. If you're working on this on your own, write some flashcards, memorize this. It comes up on the SAT or the ACT a decent amount, beyond the fact that it's just useful to be on top of your special rights, and it really helps later on with the more trig we do, knowing your special right triangles and those ratios. So get those things handled. We did it. We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it. You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.